Hi everybody, in this video, let's look at dependent event and independent event. Let's look at the example. There are 4 white marbles and 2 black marbles inside the box. 2 marbles are chosen from the box, one by one. Find the probability for, now we have 2 situations here. The first situation, find the probability for Liu picking 2 different color marbles if the second marbles is picked after replacing the first picked marbles back into the box with replacement. So the first time you pick the marbles, there are 6 marbles inside the box. And the second time you pick the marbles, still the same. There are 6 marbles inside the box because replacement. Okay, so for the second situation, Liu picking 2 different colors, same thing, but this time without replacement. So this means that the first time you pick the marbles, there are 6 marbles inside the box. The second time you pick the marbles from the box, there are only 5 marbles left inside the box. So the way how we find the probability for the first situation and the second situations are different. Now, let's look at first situation. We want to find the probability for Liu picking 2 different color marbles. So this is with replacement. So there is a mistake that some students might make. So some students might draw this tree diagram. This is for part A. Because we know there are 2 colors of marbles inside the box, right? White or black. So first marbles, white or black. Second marbles, still the same. We have 2 color. White, black, white, black. And they start to counting this way. So we want to find the probability of getting 2 different color. So this means that white, blue, sorry, not blue, black, white, black, or black, white, right? So total we have 1, 2, 3, 4. And there are 2 outcomes that we want, white, black, or black, white. And you get the answer 1/2. This is actually not correct because there are actually 4 white marbles. If you want to calculate like this, you still can use a tree diagram, but we need to draw W1, W2, W3, W4. Why? Because there are 4 white marbles and you have 2 black marbles. We need to write B1, B2. And up you will get a tree diagram like this. So which has a lot of branches. So it actually takes time and it needs a lot of space. So normally I will not suggest you to do that. So I still can draw another diagram for you. I will use graph to show you all the possible outcome. Okay, now. But we actually can use this tree diagram. Later on I will show you if you want to use this tree diagram. You don't want to draw this, we still can solve it, but the way how we get the answer is slightly different. Now, there are total 6 marbles inside the box, right? So I'm going to draw 6 vertical lines. Let me draw 6 vertical lines to represent 6 possibilities. 1, 2, 3. Okay, 6 vertical line. So second time still the same thing. There are also 6 marbles inside the box. So I'm going to draw another 6 line, but this time go horizontally. 1, 2. Okay, so let me label. This is for the first marbles. We have 4 white marbles, so I'm going to label W1, W2, W3, W4. So I have 2 black marbles, B1, B2. So for the second marbles, still the same thing. We label exactly the same thing here. W1, W2, W3, W4, B1, B2. Okay, all these intersection points are all the possible outcome. So total we have 1, 2, 3, 4, 5, 6. You have 6 here, so 6 times 6 you will get 36. So total we have 36 possible outcome. So if we want to find the probability of getting two different color marbles, so here will be 36. Let's look at this. We want two different color, right? So if the first marble pick is white, so the second time must be black, right? So it will be this. Same thing, white pair with black, white pair with black, white. Okay, so if the first marbles is black, so the second marbles must be white, because we want two different color. Okay, so total we have how many outcome here? 1, 2, 3, 4. Okay, we have 16. So if you simplify it, divided by 4, here you will get 4, 4, 16, 9, 4, 36. Okay, this is the correct answer. Not this one, but this. So if you want to solve it this way, can we get the correct answer? Yes, we can do it this way, but this time slightly different. There are 6 balls inside the box. What is the probability of getting a white, not ball, sorry. There are 6 marbles inside the box. What is the probability of getting a white marbles? It will be 4 over 6, right? 4 white, total 6. So it will be 4 over 6. What is the probability of getting a black marbles? 2 over 6. Okay, now I'm going to fill in the probability into near to the branches here. So 4 over 6 for white. This is 2 over 6. So I suggest you don't go and simplify it, because if you write 4 over 6, it's clearer. You know that there are total 6 marbles and 4 are white. So for the second time, because this is replacement with replacement, second time still the same thing. There are 6 marbles inside and 4 of them are white. 6 marbles inside, 2 of them are black. Okay, here also the same thing. After fill in all the probability, you have to always make sure that the sum of the probability for all these branches, this and this, must be equal to 1 every time. Add up together must be equal to 1. Okay, now we are looking for different color, right? So it will be white, black, or black, white. So the probability of getting two different color marbles will be white, black, 4 over 6 times 2 over 6. Or I write this one first. Black, white, black, or black, white. So probability of getting white, 4 over 6, time probability of getting black, 2 over 6. Black, 2 over 6, white, 4 over 6. So 2 times 4, you get 8, 6, 6, 36. 16 over 36. So if you simplify it and divided by 4, you get exactly the same answer. This is another way that we can use to solve this type of question. So personally, I would suggest you to use this instead of this, because this you need to draw a lot of line. It takes time. So this will be faster. So this is with replacement for the first situation. Now let's go to the second situation without replacement. Okay, the second situation is without replacement. Means that the first time you pick, there are 6 marbles inside the box. The second time, there are only 5 marbles inside the box. But we still can draw this diagram. It's okay. 6 is okay. But we need to be more careful. We need to be more careful. We need to know that W1, W1, W2, W2, this pair, impossible. Because after picking W3, you put outside. It's impossible for you to get the second time W3. So all this outcome where I make a cross, all are not possible outcome. So total, we have how many outcome? 6 times 6, you will get 36, minus this 6, you will get 30. Okay, so still the same, we want to look for 2 different color. So white will be need to pair with black. White, black. White, black. White, black. So if the first marble is black, need to pair with white. Okay, see the same thing. Okay, there are 16 pair. 16 pair. So if we simplify it, divided by 2, divided by 2, you will get 8 over 15. So if you want to use this tree diagram to help us to get the answer, can we get exactly the same answer? Yes. Let me show you here. Let me draw another tree diagram for you. The tree diagram drawn will be the same as this one, but the way how we fill in all the property here will be slightly different because this is without replacement. White, black. White, black. Here the same thing, white, black. So this is the first marbles. Oh, let me write again first. So this will be second marbles. Okay, so let me start writing all the probability for every branches. For every branch here. So here will be 4 over 6. Here will be 2 over 6. So for the next time, you need for the second marbles, you need to be more careful because this is without replacement. So second time, when you want to pick the ball from the box, there are only 5 marbles inside the box. So let's say if the first marble pick is white, so the white number of white marbles inside the box will become less 1, right? So now it will be 3 only. Okay, so here still same 5. Black we have 2. So after writing the property, always double check the sum of the sum for the property for all the branches here must be equal to 1. Equal to 1. Okay, so let's say the first marble pick is black. So there are 2 black marbles inside the box, right? After picking 1 black marbles, there is only 1 left inside the box. So here will be 1 over 5. Be careful, not 1 over 6, because second times when you want to pick the marbles from the box, there are only 5 marbles inside the box. So here also 5. White marbles, we have 4. Double check, this plus this must be equal to 1. Okay, so now let's see, can we still get the same answer using this method? Probability of getting 2 different color marbles. So we want white, black or black, white. We still can use this multiplication rules, but you will notice that the property will actually change. So white, black will be 4 over 6 times 2 over 5 plus black, white 2 over 6 2 over 6 times 4 over 5. 4 times 2 you get 8, 6, 5, 30. 2, 4 you get 8, 6, 5, 30. So eventually, let me erase this one first. This is 16 over 30. If you simplify it, you will get divided by 2, divided by 2. Here you will get 8 over 15. Okay, we still get the same answer. Now, you try to observe these two tree diagrams. You will notice that for the first situation with replacement, the probability of getting white always 4 over 6. The probability of getting black always 2 over 6. No matter what is the first marble picked, right? In this situation, we call this combined event as independent event. Independent event. Now you try to look at the second tree diagram, this without replacement. You will notice that the probability of picking a white marbles and a black marbles will always change. For this is 4 over 6. For this is 2 over 5. Right? Okay, let me double check again. Oh, sorry, not 2 over 5. Should be 3 over 5. So for this is 4 over 6. And this 3 over 5. And this 4 over 5. Same thing happened for picking a black marbles. This is 2 over 6. This is 2 over 5. And this is 1 over 5. Why? Because it is affected by the what is the color of marbles that you first pick. So in this situation, we call this combined event as dependent event. Let me write over here. For this, without replacement, this is dependent event. But when we want to find the probability, we still can use this multiplication rules, but you need to be more careful. Without replacement, when you want to fill in the property for the second part here, you need to be more careful. Okay, let's look at one more example. A fair dice is tossed and followed by choosing a color card from the bag consists of 4 white, 3 yellow, and 5 black cards. So total we have 12 cards over here. So for a dice, we will be getting 1 or 2 or 3 or 4 or 5 or 6. Let me write over here. 1, 2, 3, 4, 5, 6. Calculate the probability that an even number and a yellow card are chosen. So let me use this diagram to help you to visualize all the possible outcomes first. But in the exam, I think in this situation, I will not encourage you to draw this because it takes time. Probability of getting even number and a yellow even number and a yellow card. So it's very important you know all the term, the meaning of the term that you have learned before, like for example, even number, odd number, prime number, consonant, vowel, multiples, factor, and so on. Okay, let's find the probability for part A. Even number and a yellow card. Let's look at this one. So fair dice, 6 possibility. 1, 2, 3, 4, 5, 6. Because for white card, I write W1, W2, W3, W4. 3 yellow card, Y1, Y2, Y3. And 5 black card, B1, B2, B3, B4, B5. You'll notice that I draw a lot of line over here because I want to visualize every single possible outcome. Okay, even number, so it will be 2 or 4 or 6, right? So need to pair with yellow card. So it will be this. So here we have 6 Here we have 12. 6 times 12 will be 72. 1, 2, 3. So we have 9 outcome are even number paired with yellow color card. Okay, so just simplify it, you will get 1 over 8. Okay, let's say if you don't want to draw this diagram, can we do it another way, which is faster? You can just simply draw a tree diagram. If you can imagine inside your brain, you don't have to draw the tree diagram, it's okay. But at the beginning, I think better I show you the tree diagram. For the dice, even, oh, not even, even, this is odd. If you don't want to write odd, you can write not even, it's okay. This diagram is just for your own reference. So for the second, this will be card, right? So we have how many color? We have 3 color, 1, 2, 3, 3 color. So I'm going to draw 3 branches here. 3 branches. White, yellow, black. White, yellow, black. Okay, so what I'm looking for is even pair with yellow color. Mean here, and even yellow color. Okay, this will be the one we need. Why do I write 6? Because there are 6 possibilities for a dice. 1, 2, 3, 4, 5, 6. So how many even are there? 2, 4, and 6, right? 3. Okay, so yellow color. Let me write the probability over here. So we have 12 cards. Among the 12 cards, there are 3 yellow color. So what I need to do, just take this one, multiply by this one. 3 over 6 times 3 over 12. Okay, this one, you can simplify it. Here also can simplify it. Divided by 3, divided by 3. So 1 times 1, you get 1. 2 times 4, you get 8. I think this method will be faster. If you can visualize, if you can imagine it, you don't have to draw this diagram, it's okay. But I think drawing this diagram will not take you a lot of time, so it's better you draw it out. When you see the diagram, it's actually easier for you to solve it. So both methods, using this or this, give you exactly the same answer. Let's try another 2. Okay, now let's look at second part. Let me erase this one first. So same thing, I'm going to show you 2 methods using this and this tree diagram. A card which is not black is chosen. So for the dice, no matter what number is okay, as long as the card is not black. So we have a lot here. Not black, it means all of this. Okay, all of these outcomes are accepted. As long as it's not a black card, it will be accepted. So total we have 72 possible outcomes. So there are 1, 2, 3, 4, 5, 6. 42 pair can be accepted. So 42 over 72. You can just use a calculator to simplify it. Divided by 6, divided by 6. Oh, sorry. Divided by 6. Okay, so it will be 7 over 12. This is the answer. So how about if, let's say if some student don't want to do this, it's okay. You can just take 1 minus black color. You will still get the same answer. Let's say if you want to calculate this one. Because the question don't want black color card, right? So you can find the probability of getting a black color card. Then you take 1 minus that probability. You will still get the same answer. Okay, this one you can try yourself. Let me show you another method using this tree diagram. Okay, not black color. Here, this 4. So you can find the property of this 4, add up together. Or you can do it this way. I don't want this. This I don't want, this I don't want, right? Because the question is talking about not black is chosen, not a black card. So I will take 1 minus this 2. So how do we get the property for this 2? Even number, okay, just this 3, 1, 2, 1, 2, 3, 3 over 6. Here will be 3 over 6 as well. Always double check the sum of the property for all the branches must be equal to 1. So black, we have 5 black cards out of 12. So 5 over 12. So here the same thing, 5 over 12. So it will be 3. We want this. We don't want this. That's why I take 1 minus this. Three over 6 times 5 over 12 minus 3 over 6 times 5 over 12. Okay, so just press your calculator. You will still get the same answer, 7 over 12. Okay, let's proceed to the last part. A prime number and a white card. So this time it's not talking about even or odd, but it's talking about prime number. Okay, so that means I still can use this diagram. Here also the same thing. Prime number, I hope that you still remember what is a prime number. So the first prime number will be 2. This is prime number, this is prime number, this is prime number. Prime numbers only has 2 factors. And all the prime number are odd number except 2. 2 is the only prime number which is even. So we want prime number and white card. So prime number and white will be here. Prime number and white. Prime number and y. Okay, so we have 1, 2, 3, 4 chances. So we have 12 pair over here, and total possible outcome is 72. So 12 divided by 72, you can simplify it. Divided by 12 divided by 12. So the answer is 1 over 6. So let's say if you want to use this tree diagram, yes, we still can use this tree diagram, but here it's not talking about even or odd. It's talking about prime number or not prime number. Not prime. Okay. So how many prime number we have here? 3. So it's still the same, 3 over 6. Here also 3 over 6. Always double check the sum of the property for all the branches must be always equal to 1. Okay, we want white card. So it will be here. White 4 out of 12. 4 out of 12. Okay, let me use this method, see whether we still can get the same answer or difference. 3 over 6, we want this prime y. Okay. Prime 3 over 6 times y, 4 over 12. Let me simplify it. Divided by 3, divided by 3, divided by 3, divided by 4, divided by 4. 1 times 1 you get 1, 2 times 3 you get 6. We still can get the same answer. So it's totally up to you. We want to use this method or this method. Personally, I think this method will be easier and faster. Okay, that's all for this video. See you next time. Thanks for watching. Bye bye.